So this is Dr. Kavita Singh, Associate Professor in the Department of Civil Engineering, Institute of Aeronautical Engineering. Today we are going to discuss a topic called as GIS applications in real life, Part 2. So in the previous lectures we have already discussed about this GIS applications in our real life in the different various fields. So there are many applications which we are going to discuss. In the previous lecture we have already discussed the 2-3 topics related to this. Now today we are going to discuss about different topics related to this GIS applications in the real life. So let us go through the contents what we are going to discuss today. So through the contents we will see urban and regional planning applications of GIS, wetland mapping, land use land cover applications, and geologic and soil mapping. So these are all different types of applications in GIS in our real life, day-to-day life, how we are using GIS in these various fields. So let us start with this first topic, that is about the urban and the regional planning of the applications. So what are the urban and regional plannings of the applications? We'll just get to know. So what is urban and regional planning? So what is urban and regional planning? So what is urban planning? So to plan a city, we need two types of data. We need a spatial data, and we need a non-spatial data. Okay, non-spatial data. So I hope you remember what is spatial and non-spatial data. So to plan a city, we need both types of data. These both types of data are required to plan a city. So GIS in urban planning enables the spatial analysis and modeling. So what is spatial analysis? By using the spatial data like topo sheet data, satellite data, aerial photographs, that all we use it. Along with that, we use non-spatial information like along with that, we use the information about the spatial data, like what type of area present over there, how many areas, which area is suitable for the transportation, which area is suitable for the construction purpose. That all we are going to plan based on this urban and regional planning applications in GIS, which can contribute the variety of important urban planning tasks. So for the decision makers, it will be more easier to understand about this type of planning of a city. So these tasks includes the site selection, land suitability. This is very important. Land suitability means type of land suitable for construction. Okay, type of land suitable for construction or transportation. Based on our requirement, which type of construction we are going to do. So that land suitability analysis, land use and transport modeling, the identification of planning action areas and impact assessments can be done with the help of the GIS process. Okay, so next we'll see how GIS is applied in urban and regional planning. So how it is applied in the urban and regional planning. So in spatial analysis, if we see spatial analysis, GIS enables the planners. So planners and decision makers, it enables the planners and decision makers to analyze the spatial relationships and patterns within the urban and regional areas. So this is the GIS is going to help for the planners and decision makers to take a further decision that which area is suitable for which type of construction. That all can be done with the help of the GIS process. So this includes the assessing the land use, transportation networks, population distribution, environmental factors and infrastructures can be included with the help of this process. Now a site selection, for example, for the urban planning. Site selection is very much important. Suppose this is the plan. Okay, this is your plan. So here is your site. So along with this site, what are the around features? So the buffer, if we see for the 10 kilometers buffer, so what are the surroundings area is present over this particular site, location for the various developments such as residential areas, commercial zones, industrial parks and public facilities based on the factors. So that GIS will help you to select the site. Suitable site, where we can just go with the locations and further how we can go for which type of construction, either it should be residential, commercial, industrial or public facilities based on the factors it is decided. So like accessibility, land suitability, environmental constraints, and proximity to the services it is provided. Next, transportation planning. We will talk about the transportation planning, how the transportation planning is helpful, how the GIS is helpful in transportation planning. So GIS is used to analyze and optimize transportation networks. Planners can model traffic flow, evaluate the alternative routes, public plan and transit routes. Like suppose this is the plan for a city, for an urban area, we can say, for an urban area. So this is the plan. So which type of road? So let us say there is a highway can be constructed here. So highway construction can be done. Highway construction can be done. Now we have to construct a local road. Okay, local road construction can be done, and here small houses can be constructed based on the type of the transportation planning. The transportation planning should be in such a way that the area should connect. It should connect to each other. Suppose one more road will connect to here, one more road will connect here, this will connect here, this will connect here. So based on that, it has to see that main road should be connected to the highway. So main road should be connected to the highway, or what are the different routes related to that, that all can be done with the public transit routes. So and assess the impact in transportation projects on surrounding environments and the communities based on that. Now, urban growth management. So, what is urban growth management? So, GIS helps in managing urban growth. So, GIS will help you to manage the urban growth. How can we manage the urban growth? By monitoring changes in land use pattern, population density, and infrastructure development over the time. So, population density can be managed and infrastructure development can be managed. These all can be managed based on the urban growth management. So, all the data are received, like spatial data and non-spatial data will be received based on this population, and it will be managed based on the GIS process. So this information is crucial for predicting the future growth trends, planning accordingly to prevent urban sprawl, maintain the sustainable development. Sustainable development, what is sustainable development? So developing the future. So developing the city in sustainable way. Sustainable way means the resources should be managed. Resources should be managed. Okay, managed properly. Resources should be managed properly. It's called as sustainable development. Like in the present situation, it should be in that form that it should be utilized for the present situation, present people, and as well as for the future generations also. It is used. So the resources should be managed in such a way that it can be used in the present and the past. Next, when you talk about the wetland mapping, this is another application of GIS in the real life. So wetlands are recognized as one of the world's most valuable natural resources. So wetlands are recognized as one of the world's most valuable natural resources. So in the world, the valuable resources, why it is needed? Because increasing world population, human demands on the wetland resources for agricultural expansion and urban development continue to increase. So agricultural expansion and urban development will continue to increase, so that wetland areas are identified for the valuable natural resources for the agricultural purpose, for the resources like urban development. If we just consider this as a developmental area or developmental land, so wetland mapping is very much important to find out the present scenario and the future scenario, and what type of condition is there in the present area that can be mapped with the help of the GIS, and decision makers and planners can come to that conclusion that this area is suitable or not for the construction purpose or any other purpose. So geographic information system and remote sensing technologies have proven to be useful for mapping and monitoring wetland resources. So they have proven to be useful for mapping and monitoring wetland resources. So GIS and remote sensing, both are technologies have it's a very important or useful tool for mapping and monitoring the wetland resources. It can just tell you about which areas are having the present situation, which areas are having more types of wetland, where can be agricultural activities can be taken place, and the wetland resources also, how much area is available with that kind of resources. So that all information can be given with the help of the spatial and non-spatial data with the GIS process. So recent advances in geospatial technologies have greatly increase the availability of remotely sensed imagery with better and the finer spatial, temporal, and the spectral resolution. So these are the resolutions. If you remember, I hope you remember in satellite remote sensing data, remote sensing remote sensing satellites. So you have different types of resolution, like spatial resolution, spectral resolution. You have radiometric resolution, and you have temporal resolution. These are all types of resolutions. If we see 1, 2, 3, 4 types of resolution, the GIS is remote sensing satellite is having. So it will help us to give a spatial, temporal, and the spectral resolution with the help of the recent advances technology. The present situation, how much developmental activities are going on in the present scenario, and in the continuous situation, what would be the present condition and the future condition of that particular area can be given with the help of this remote sensing data. With the help of the spatial resolution, it will give you this clear picture of that area. And with the help of the temporal resolution, the different changes in that city or the changes in that area will be provided by the resolutions. And spectral resolution will help us to show us the different types of crops grown in such regions, and what type of vegetation is grown, and how the development of the urban areas are properly developed near the wetlands fields that can be helpful with the help of this spectral resolution. Now, how wetland mapping is typically conducted using GIS? How it is conducted using GIS? So, data acquisition and the pre-processing. So, what is data acquisition? Data acquisition is like with the help of remote sensing, okay, aerial photography, and you have this different types of raster data. So this data is acquisition is done, and later the pre-processing of this data is done. Pre-processing means converting the data into the readable format and conducting this pre-processing. The brightness, the contrast, and the proper view of the image should be there. So often used to identify the wetland areas based on spectral signatures and indicate water presence and vegetation characteristics. So I hope you remember what are the spectral signatures. Spectral signatures will show you the graph like this, with a peak and valley configuration like this. It will show you the graph like this, where the spectral band will start from 0.4 to 0.7 to 1, 2, 3, 4, 5, 6 nanometers. Okay, nanometers. It will start like this. So it will show you the peak and valley configuration. So based on this peak and valley, we can just find out the different types of vegetation or different types of crops in such regions, which will help us to know the type of the soil, which will help us to know the type of the present water body or wetland situation. It will tell us about the condition of that area. Now, field surveys, ground truth, and through field surveys, it is essential to validate and supplement the remote sensing data, especially for the complex wetland types on small scale features. So, few of the wetland features when you are trying to do the data acquisition with the help of remote sensing. So, few areas are not able to identify properly. In that case, you have to go with the ground truth process through field surveys. It can be done. You have to go to such places, so complex places, and find out the condition of the present data. Now, data integration and analysis. So, image classification, remote sensing data is processed using image classification techniques. Image classification techniques are supervised and unsupervised classification. So, what is supervised classification and unsupervised classification? So, if you remember in the previous lectures, we have learned about supervised and unsupervised classification. In the supervised classification, it will let us know the training pixels are provided to get the exact information, and in unsupervised classification, the training pixels are not provided for the classification to categorize and rank our types, including the wetland based on the spectral characteristics. So GIS overlay analysis also can be done. So spatial analysis techniques such as overlay operations are used to integrate the various datasets like land cover, hydrology, soil types to delineate the wetland boundaries and assess their characteristics. So what is overlay analysis? Overlay analysis, if we talk about overlay analysis in GIS, so suppose this is a layer 1. So you have another layer below this called as layer 2. So you have another layer called as layer 3. So you have a different layers, layer 1, 2, 3. So these layers are overlaid together, like you have a land cover, and second layer may be hydrology, and third layer may be soil types. Okay, soil types. These are all overlaid together. And it will match the geometry of the each layer to delineate the wetland boundaries and assess their characteristics. Now, hydrological modeling. What is hydrological modeling? So, GIS-based hydrological models simulate water flow and accumulation patterns, aiding in identifying hydrologically connected wetland complexes. Now, wetland classifications, when we talk about the classification system. So, wetlands are classified based on their hydrology, vegetation, soil characteristics. So, based on their hydrology, vegetation, and soil characteristics. So, these are the three types where the wetlands can be classified. So, what is hydrology? Hydrology is related to the water body present in such area. Like if the river is present, or lake is present, or any kind of pond or water body is present, so that all comes under the water body or hydrology we talk about. So if the water body is more, if the hydrology is more much water if it is present, then it is area is totally having the moisture content more in the soil. Okay, and vegetation, which type of vegetation will grow over that such regions will tell us the type of the soil present in such regions. So generally the vegetation grown in areas wherever the wetland soil is available will be more, and it will be evergreen, and the greenery will be more in such regions. And the soil characteristics also will say us the wetland classification, because all of the soils are not having such properties where the vegetation can grow. So most of the soil, like sandy soil, if you talk about the sandy soil, loamy soil, it will not be helpful to grow more number of vegetations. But whereas when we talk about the soils which are alluvial soils, are very fertile soils where the vegetation can grow more intense in quantity. So that type the soil characteristics will also help us to classify the wetlands, like systems like the covering classification system adopted by the US Fish and Wildlife Service categorize wetlands into types such as marsh, swamps, bogs, and fens. Okay. Now, attribute data. So, GIS allows integration of attribute data. Example, water rigging plant communities with spatial data to create a comprehensive wetland maps. So, that provides a detailed information on the wetland type and the condition. So, detailed information about the wetland type and the condition will be providing more detailed information on the wetland type and the condition of the attribute data is what you know about attribute data. No? So attribute data is about the information about the spatial data. So GIS allows to integration of attribute data. So suppose you have a spatial data, and you have a non-spatial data. So non-spatial data itself is known as the attribute data. Okay, so these two are integrated in GIS. When it is integrated in GIS, when spatial and non-spatial data are combined together, when the non-spatial data is linked to the spatial data, then it is called as the integrated in GIS. So that data are integrated in GIS to get the output of that area, or output of that result of that map, and wetland maps that provide detailed information on the wetland type and the condition. Next, when you talk about the monitoring and management, so in monitoring and management, we have change detection. So what type of monitoring and management can be done? So continuous monitoring of the data like vegetation data, crop, agriculture, or water body or construction works, that all When you talk about the wetland, then we are talking about the agriculture or the vegetation or the soil type. So all the change detection can be done with the help of the GIS facility. And so GIS facilitates the monitoring changes in the wetland extent and condition over time by comparing the historical and the current mapping data. Historical and the current map data. So comparison of historical data with present data. Okay, present data. So when you compare these two, you'll get to know, and this comparison can be done in GIS. Okay, so GIS will compare the historical data and the present data, and it will tell us about the changes in the previous years and the current year. Mapping, when you do the mapping of these areas, and this helps in assessing the assessing the impacts of the land use changes in the climate variability. So it will help us to assess the impacts of land use changes. So what are the land use changes happen in such areas will be identified, and GIS will help us to tell us about the land use changes and assessing the impacts in such areas. So conservation planning. So wetland maps generated through GIS support conservation efforts by identifying the priority areas for the protection, restoration, sustainable management practices. So conservation and planning wetland maps generated through the GIS support conservation efforts by identifying the priorities of areas of protection. So what are the areas which are needed for the protection and the restoration and the sustainable management practices will be identified with the help of the GIS mapping, where you can just find out and you can identify and just target such places for the restoration and the protection of such areas, and for the help of the sustainable management practices can be identified with the help of the GIS process. Third thing, application where we have seen this many times, we have come across this word called as land use and land cover. When you're talking about the land use and land cover applications, so LULC application change detection using remote sensing and GIS technique is a cost-effective method of obtaining a clear understanding of land cover, alteration processes, and land use changes and their consequences. So when you talk about the GIS applications in the land use and land cover, so land cover classification and mapping. So to what is land use and land cover? This every time I will tell you land use and land cover. So these are the two different things. So land use is utilization of the land. Utilization of the land. Okay. Land cover is which is naturally covered. So these are the two different classifications generally when we talk about the land use patterns. So land use and land cover. So most of the parts it's utilized by the human activities like transportation, construction of buildings, industrial areas, commercial areas, settlements, and different types of construction works which are going on the earth's surface. So that all comes under the land utilization, or agriculture is under the land utilization, transportation is under the land utilization. So these are all land use. So to identify and classify different types of land cover, remote sensing data, forest, water bodies, and urban areas, we can just find out with the help of the mapping purpose. We can do the land use and cover mapping, and we can identify which areas covers with the forest, which areas are covered with the water bodies, and which area is covered with the urban areas. So GIS tool processes satellites or aerial imagery to classify land cover types using algorithms such as supervised and unsupervised classifications. Land use mapping and analysis. So what is land use mapping and analysis? To map and analyze how land is used for various purposes such as agriculture, residential or commercial activities can be analyzed, and it can be identified. So GIS integrates land use data with the other spatial information. It integrates the land use data with the other spatial information to create detailed land use maps. So detailed land use maps means it can be village-wise, mandal-wise. Okay. So detail or cadastral also we can say cadastral-wise. So these are the detailed land use map we can say with the high resolution, or we can say with the large scale mapping. Okay, large scale mapping. large scale mapping is what? So scales like small scale and large scale, we're talking about the detailed land scale. So there are two types of scale. One is small scale, other one is large scale. Okay. Now in small scale, when you talk about 1 is to 20,000 and 1 is to 1,000. Okay. So which one is the large scale? So 1 is to 1,000 will be the large scale. Okay. 1 is to 20,000 is the small scale. Why? Because here, when you are seeing here, detailed land use map. Detailed land use maps means it will be providing more and more detailed information on 1 is to 1,000. Of course, the area coverage will be less. So the area whichever it will cover, it will give you the very detailed information about the areas and analyze the spatial patterns and the trends. Now, urban and regional planning is to support the planning and development decisions by analyzing the land use patterns and the land cover. Now, GIS helps in zoning land allocations. It will help you to allocate the land mapping and infrastructure planning by providing the insights into the current land use and the potential impacts of the new developmental activities. Now, environmental impact assessment also comes under the land use and land cover. So, to assess the environmental impacts of land use changes of new developments, what is environmental impact assessment? We call it as EIA. So, what is environmental impact assessment? The assessment is done. Assessment is done for what? Assessment is done for the any project work when it is going to be developed to approve the project. Okay, so there is an assessment team which will approve the impacts of that particular project in such area. If any project is going to be developed in such area, so the environmental impact assessment team will assess that what will be the impact after this. This project will take place here, this project will run in such region. So what will be the impact to the environment and the human life and the animal life? To assess the environmental impacts of land use changes certain new developments. GIS environmental impacts like habitat loss, pollution changes in ecosystem services, aiding in the development of mitigation strategies, and change detection and monitoring. So to monitor and detect the changes in the land cover and land use over time. So what are the changes will take place at the such areas, like what are the changes in the construction work, what are the changes in the developmental activities, that will be monitored when we check the historical data and the present data. We can just compare the data and just we can find out the changes in the present scenario and the past or the future scenario. So GIS compares the historical and current imagery of data and identify changes such as deforestation. So deforestation, it is not like regularly it happens. So most of the places wherever the urban activities are going to be developed, so that such areas the deforestation will be taking place very often. So that such areas we'll see with the help of the change detection and monitoring. So GIS can help you to compare the areas like before or 1 year before, how was the condition. Most of the areas will be covered with the forest. After 1 year, what is the condition of such area? That changes can be monitored with the help of this GIS process. So change detection and monitoring can be done with the help of the GIS process. So urban expansion and land conversions also will be taking place. So that all information can be done with the help of the GIS process. Next, when we talk about geological and soil mapping, so this is one more application of GIS in the real life. So what is geologic and soil mapping? When we talk about geology, we are talking about the rocks and minerals, okay, or soil, or that all information that we are talking about. So that is totally dependent on the construction work. When you are going in a real life construction, we have to just go through the geologic condition and the soil condition, and then only we have to finalize the construction work. So the application of the remote sensing in geology means the scientist can use the electromagnetic radiation to collect the detailed information all over the world. So what is the electromagnetic radiation? Electromagnetic radiation is what? Radiation which is coming out from the sun. So when you measure in the electromagnetic spectrum, so where it reflects, which area it reflects, so all the features which is present on the Earth's surface will be reflected or observed or re-emitted. Based on that, the curve will be formed in the electromagnetic spectrum. region. Okay, so based on that, scientists they can use this electromagnetic radiation to find out which type of soil and which type of land or geological features are present on its surface. Based on that, only the construction works can be decided for the humans. So key components of geological mapping. So what are the key components? Rock types and structural features. So what is rock type? So type of the rock to identify and mapping different types of rocks. Like there are different types of rock, igneous rocks, sedimentary rocks, and metamorphic rocks, and their distribution. If they want to find out the distribution, where they are distributed, and which type of rock is suitable for which type of construction can be mapped, and based on that only the further decision can be taken. So structural features, documenting the geological structures such as faults, folds, and joints. We can just find out about the faults, folds, and joints. So what are the structural features? We can just go through and the maps which is prepared by the Geological Survey of India. There they can just tell you about what type of faults are present in such area, and based on that the construction activities can take place, whether it is suitable for the construction of the transportation, suitable for the construction of the industrial activities or commercial activities. Based on that, the structural features will be decided. Next, when you talk about the stratigraphy, so mapping the sequence of rocks, layers, and the historical deposition. This will help us to find out what are the deposition present in the sequence of the rocks. So what are the layers present in the Earth's surface? So that layers also will tell us about which type of layer is forming. So these are all layers of the rocks. Will tell us about the layers of the rocks. Will tell us about the features present on the Earth's surface. So mineral resources, like identify the areas with the potential minerals or energy resources. That all minerals can be identified in the situations, and it can tell you about the potential minerals or the energy resources about that. On geological history, what are the geological history? Understanding the geological process and the events that shaped in the area. So what are the geological areas present in that features about areas? That understanding the geological process. What is the geological process? Is about the rocks and minerals. Will tell us about the processes and the events that are shaped in that such areas. Will tell us the history, and based on that we can just go for the construction work practices. So GIS application in geologic mapping. So data integration. What is data integration? GIS integrates the various data sources such as field service, satellite imagery, remote sensing to create comprehensive geological maps. So data integration, it integrates the various data sources such as field surveys, satellite imagery, remote sensing to create the comprehensive geological maps. So integration means integrating the spatial and non-spatial. Spatial and non-spatial we can do. So this two integration can be done with the help of the GIS process. Satellite image is a spatial, and non-spatial data can be integrated with the help of this GIS process. 3D modeling can be done. So GIS can generate 3D models for geological structures to visualize the subsurface formations and interpret the geological data. Now, spatial analysis, GIS allows for the analysis of the spatial relationships between different geological features such as proximity of mineral deposits and the faults. Spatial analysis, it will allow us to find out the relationship between the different geological features and different mineral deposits in the such areas. Now, visualizations, GIS tools provide the interactive maps and visualizations that help geologists and stakeholders to understand the complex geological information. So this was about the geologic and the soil mapping. So today we have studied about, learned about the different applications in the real world, how it is applicable, how it is helpful in our day-to-day life, how it is helpful in the construction activities, how it is helpful in the urban development, and how can we find out the wetland mapping. So this all GIS will help us to give a decision and take a proper decision with the help of the historical map as well as the present map, the detailed map information will provide us to get the more information about such areas, and we can just depend on that kind of data, and decisions and planners will be taking that data for utilization for the further construction activities or further developmental activities in any city or any area which is decided to be developed. So this was about the GIS application in the real life. And So these are the references which you can go through to find out more content about the GIS application in the real life. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.